Welcome to TSAT. Today I am going to discuss a topic in geography regarding moisture, condensation and precipitation. So, what do you mean by this moisture, condensation and precipitation, and what is the impact on weather and climate? We need to be clear with this. So, here in this context, moisture is the amount of water vapor present in the atmosphere. So, humidity is expressed in different ways. So, the moisture or the humidity is the amount of water vapor present in the atmosphere. It is being expressed in different ways. So, what are the different ways this existence of moisture in the atmosphere can be explained? So, different kinds of questions are asked regarding the availability of moisture or the measurement of moisture in the atmosphere. One way is absolute humidity. So, what do you mean by absolute humidity? The weight of actual amount of water vapor present in a unit volume of air, it is expressed in grams. So, the amount of water vapor present in the air in grams per unit volume. So, for example, is known as absolute humidity. So, the absolute humidity, for example, the amount of water vapor an air can hold is being impacted by temperature, the same volume of air. When there is high temperature, the capacity of the air to hold water vapor increases because the air expands, the intermolecular space increases and the amount of water vapor to hold by air increases. So, that is the reason why even though the volume of air is the same, for example, 1 cubic meter of air, with the increasing in the temperature has been displayed here. For example, at 10 degrees Celsius, a cubic meter of air can hold 11.4 grams of water vapor. This is at 10 degrees Celsius, but it is not the case. With the increasing in the temperature, the same volume of air has got the capability to hold more amount of water vapor. For example, 1 cubic meter of air at 21 degrees Celsius can hold 22 grams of water vapor. So, absolute humidity is comparing between the volume of air and the grams of water vapor present in the volume of air. That is what absolute humidity is. It is a comparison between the volume of air and weight of water vapor. Next, specific humidity. The weight of water vapor to the weight of air. So, here previously one is the volume and the second is the weight, but here the ratio is between both the weight of air and the weight of water vapor. That is the fundamental difference between absolute humidity and specific humidity. So, depending upon the question, to confuse you, different statements are being made in the objective question, so that you must be able to answer in a right manner knowing this difference. Next, relative humidity. Relative humidity is the humidity which is expressed in the news bulletins expressing the probability of precipitation. So, the probability of rainfall is been expressed in relative humidity, which is the ratio of air's actual water vapor content to its water vapor capacity at a given temperature is relative humidity. Means, for example, you have got a cubic meter of air. The capacity at the temperature, for example, at 20 degrees, if it is 20 grams of water vapor, at this 20 degrees, 20 grams of water vapor leads to saturation of air. Saturation means the point at which it starts raining. The air cannot hold water vapor anymore. So, when the air reaches a point where its capacity to hold water vapor is reached to the maximum extent, that particular stage is known as a saturation point. When an air reaches saturation point, the rate of condensation increases and it leads to precipitation, means rainfall. So, the saturation point varies with the change in the temperature. The higher the temperature, the saturation point breaks and it requires more amount of water vapor, and more amount of water vapor leads to saturation at higher temperature. When the temperature decreases, even the minimum amount of water vapor will be sufficient enough to saturate and it leads to rainfall. So, that is what relative humidity. Relative humidity is expressed in terms of percentage. So, percentage here means if relative humidity is 90%, implies that, for example, if air at 1 cubic meter has got the capacity to hold 10 grams of water vapor, if it has got 9 grams of water vapor, then the relative humidity is 90%. So, that is the way the amount of water vapor has been described in different ways. The questions can be asked by using these logic, and we need to know what is meant by latent heat in this context of understanding weather and climatic conditions. So, this is what latent heat is. The energy released as heat when the vapor changes back to liquid is known as latent heat. So, the evaporating water, so the water to change its state from liquid to vapor requires heat energy. Without heat energy, water cannot turn into vapor. So, when this vapor, when it is in the form of gas, when it changes its state from gas to liquid in terms of water, the observed energy to change its state from liquid to vapor need to be released back. So, this heat which is being released back is known as latent heat. So, latent heat is responsible for many kind of variations in terms of weather and climatic phenomena. Why, how it happens, we shall discuss. So, the latent heat of fusion means the amount of heat being observed by ice to change from solid state to liquid is known as latent heat of fusion. So, when it is changing from solid to liquid, it requires 80 calories of heat energy. When water, 1 gram of water, to convert it into ice, it must for example, ice consumes heat energy, whereas water need to release heat back to convert into solid. So, the release amount of 1 gram of water to convert into a solid ice is 80 calories. Water requires, for example, to melt ice, to melt to water, it requires 80 calories of energy to melt from ice to water, whereas water need to release 80 calories energy back to convert from water to ice. So, this is known as latent heat of fusion. In the case of latent heat of evaporization, the amount of calories of energy of heat required to convert 1 gram of water to vapor is 600 calories. In the same way, water, when it is condensing back to liquid, will release back heat into the atmosphere, further heating the environment. So, this is known as latent heat of vaporization. Latent, the meaning of the word latent here implies which is hidden, which cannot be measured on a thermometer. That is the reason why it is being described as latent. The next is sublimation. Sublimation means directly change of state from a solid to vapor without becoming liquid. So, in this process, if ice directly turns into vapor, it requires 680 calories. So, latent heat in terms of sublimation might be a question. Latent heat in terms of vaporization, the calories essential for water might be a question. Latent heat of fusion might be a question. So, in the latent heat of fusion, it is 80 calories. Latent heat of vaporization, it is 600 calories, whereas in the case of sublimation, it is 680 calories. From solid to vapor directly or vapor to solid, it consumes 680 calories. So, this is what latent heat is. So, forms of condensation. Condensation is a process where vapor is being converted into liquid, is known as condensation. So, here in this process, these forms of condensation are being described as dew, frost. So, dew is a condition where a vapor is being converted into a liquid, water vapor is being converted into water when the temperature is above 0 degrees, above freezing point. A frost is one which happens when the temperature is below 0 degrees, then only water vapor can be converted into ice. So, these are the different forms of condensation. So, fog is a kind of water droplets formed on the near to the surface of the earth or mountains, etc., because of cold conditions of the terrain. When the mountain rocks are so cold, the water vapor converts into fog is a kind of cloud, which is a low cloud being formed because of very low temperatures. This forms when we have got clear skies during winter. What happens is, when you don't have clouds, the heat from the surface of the rocks is being radiated very fastly, and these rocks get cold very fast. So because during night time, during winter, when the rocks are so cold, the moving air, the minimum available moisture converts into droplets of water known as fog, a low cloud. It is also been described as a low cloud. So mist is also a kind of fog. On the basis of visibility, it is been classified on the basis of visibility. So it is having a visibility more than 1 kilometer but less than 2 kilometers is known as a mist. So this is how condensation is being classified into, based upon the way they have been formed. So precipitation or rainfall is being classified into mainly 3 types: convectional precipitation, orographic precipitation, and cyclonic or frontal precipitation. So for precipitation to happen, the basic essential condition is saturation of air. Saturation, whatever may be the kind of precipitation, the basic condition need to be satisfied is saturation. Saturation means air reaching its capacity to hold, the maximum capacity to hold water vapor. Then it starts condensing. Condensing leads to precipitation. Condensation is a conversion of water vapor to liquid droplets. These liquid droplets suspend in the air because they are not sufficient large enough initially, which are being subjected to the buoyancy of air, which is acting against the gravity. These fine droplets float in the air, and when the temperature is below 0, these droplets freeze to form ice, and we call these droplets floating in the air as cloud, and it also contains dust particles. So when the rate of condensation increases, these clouds, these water droplets collide with one another, increasing in their size. When the weight of the water droplets is more than the buoyant force of the air, it has been subjected to gravity and it falls. We call it as rainfall. So then when the condition is the same for all these kind of precipitation, why they have been differentiated? The reason behind it is convection means the movement of material. Here, as the convectional currents in the intertropical convergence zone, as I have explained to you, with the increasing in the temperature, the water evaporates, the density of air decreases, because of which the water vapor rises above. Because of the lapse rate, the water vapor is being subjected to condensation and it precipitates. And this form of precipitation, because of the saturation happening, because of the rise of air and moisture being subjected to saturation here. Here saturation happens in 2 ways. One way is addition of water vapor by the process of evaporation. The second factor is decreasing in the temperature leads to decreasing in the capacity of the air parcel to hold water vapor, leading to saturation, leading to precipitation. So saturation can happen in 2 ways. One way is addition of water vapor to the air. Second is decreasing in the temperature leads to decreasing in the capability of the air parcel to hold water vapor. So saturation happens and precipitation happens. So because this precipitation is because of the movement of air and moisture, convection is the movement of matter leading to precipitation. That is the reason why this form of rainfall is being known as convectional rainfall. Next type of rainfall is been described as orographic. So when a physiographic feature is obstructing the directional flow of wind carrying moisture, the wind is being subjected to rise above. So as we have discussed about lapse rate, one way of saturation, even though there is no addition of water vapor, when the temperature decreases, the available water vapor itself saturates the air parcel, because the decreasing in the temperature decreases the capability of the water of the air mass to hold water vapor, leading to saturation. So what is happening here is, for example, take the case of southwest monsoons. If we assume this as Western Ghats, when the wind is blowing from the southwest direction, it is being subjected to lapse rate because of the rise, because being obstructed by this physiographic feature. So in this condition, saturation is happening in 2 ways. One way is the moisture being added because of the tropical air which is moist because of the high temperature blowing from the maritime environment. The second factor is being subjected to lapse rate because of increasing in the altitude, decreasing in the temperature. Both these factors lead to saturation and lead to one of the regions in India which have got the highest amount of rainfall in the western part of the Western Ghats, and the air on the east side of the Western Ghats become dry, leading to the formation of a rain shadow region. Is a classic example of orographic rainfall. The third variant type of precipitation is cyclonic precipitation. So the cyclonic precipitation is because of a pressure gradient being developed because of differential heating. A region which is highly heated and a region which is having not heated leads to development of high pressure. So a cyclone basically develops only in an ocean. So on the seas, these cyclones develop. It is a fundamental factor or a fundamental point which you need to mention is always cyclones develop on the oceans or seas at a high sea surface temperature, because it must create low pressure, and sea or ocean or these large water bodies are responsible for supplying the water vapor due to this high temperature are the conditions essential to develop a cyclone. And the pressure gradient must be more. At a point there must be a very low pressure point, at a point there must be a low pressure point must be surrounded with a high pressure region, so that wind blows from high pressure to low pressure, and this leads to the development of a whirlpool. At the base, what happens is the wind blows from the high pressure to the low pressure. The center is known as the eye. At the eye, rather than the winds, we experience currents, and that is the reason why the eye is calm. At this place, the wind rises vertically above, and at the tropopause, they move away from the eye at the tropopause. So at the lower surface region, they move towards the center. At the top of this cyclone, they move away from the center. Because of this reason, the extent where this wind is being distributed at the top region experiences precipitation. So this is a third type of precipitation known as cyclonic precipitation. The cyclonic precipitation, these type of cyclones are developed more in tropical regions, and they even pass to temperate latitudes in the case of Japan, etc. They are being given different names depending upon the different regions. For example, in China they are known as typhoons, in Japan and China. In Australia they are known as downs. In our country we call it as cyclones or hurricanes. So they are being given different names in different places. The other variant type of precipitation is frontal. This frontal precipitation is also known as a temperate cyclonic precipitation sometimes. So here these are known as front, means a transitional zone between a warm current and a cold current. So for example, when the warm air mass is flowing towards the cold air mass. So in this process, as per the discussion being made, the cold air mass is much more denser. That is the reason why the warm air mass cannot lift the cold air mass, and the warm air mass spreads across the surface of the cold air mass. So because of the cold nature, the air gets saturated, because with the decreasing in the temperature, the warm air, moist air carrying a warm air mass is saturated because of the decreasing in the temperature and leading to precipitation, which has been described as frontal precipitation. So in the case of Indian monsoons, is a variant of secondary type of circulation. The term monsoon has been derived from the Arabic word known as mausam, means a season. So monsoons are seasonal winds, rhythmatic winds, are also been described as periodic winds, which receive their direction with the change of seasons. So with change their direction with the change of seasons. So the monsoon is a double system of seasonal winds. They flow from sea to land during the summer and from land to sea during winter season. This can also be asked in summer how the wind direction flows from land to sea or sea to land. How the direction in summer in monsoons, the wind blows from ocean to land. In winter, the wind blows from land to sea. So, you may have a question based upon the differences between southwest monsoons and northeast monsoons. So, these monsoon winds blow northwest from the northwards from the Arabian Sea. So, southwest monsoons blow from the southwest directions towards the northern part of India from the Arabian Sea and Bay of Bengal. The monsoon winds blow from northeast towards the south towards the sea here in the case of northeastern monsoon. So, they blow from northeastern direction to southwestern direction. That is the fundamental difference here. Here southwest to northeast. The monsoon winds blow from the month of June to September. This is the time duration of the flow of southwest monsoons. The northeast monsoons blow from October to November. So, they may ask you the time duration of these northeast monsoons or southwest monsoons. They may frame a questions in terms of the directional flow of monsoons. And the third variant is of a question is the winds are the reason for the rainfall throughout the country. So, the southwest monsoons are responsible for a rainfall for throughout the country, but it is not the case with northeastern monsoons. The northeastern monsoons are responsible for rainfall in regions more concentrated towards Tamil Nadu or to the east of Eastern Ghats region, the Coromandel coast region. These winds blow during the advanced monsoon season, and in the case of northeast monsoons, winds blow during the retreating monsoon season. So, these kind of questions can be asked during southwest monsoon regarding southwest monsoons and northeast monsoons. So, what are the factors responsible for the southwest monsoon formation? So, while writing about monsoons, you need to mention the factors which are responsible for the formation of monsoons. As I have discussed in the previous session regarding the shift of intertropical convergence zone because of the shift in the thermal equator is the main fundamental reason. So, because of this reason, when the land is being heavy heated, what happens is, as I have shown to you in the previous episode, that in the northern hemisphere, which is being dominated by land, especially to the north of India, intense heating of Tibet plateau during summer months leads to development of very low pressure. Low pressure sucks the air from the high pressure regions of the ocean in the Indian Ocean region. So, which leads to development of monsoons. Next is permanent high pressure cell in the South Indian Ocean is the second factor responsible for the development of the monsoon. So, always wind blows from high pressure to low pressure, because we are in between these zones which I have discussed. We experience monsoons because this monsoon wind is being obstructed by the Western Ghats and the Himalayas, subjecting to lapse rate, and we receive rainfall. So, we receive more amount of rainfall on the western side of the Western Ghats, and we have a rain shadow region on the eastern side of the Western Ghats, and the precipitation is more towards the south of Himalayas rather than the north of the Himalayas, because of which we have got a desert in the northern region known as the Tibetan desert, whereas the southern part of the Himalayas receive this rainfall because of monsoons, which are responsible for the perennial river systems of India. The Ganges, the Indus, the Brahmaputra are because of these precipitation existing in the southern slopes of Himalayas. So, factors that influence the onset of southwest monsoons. So, what are the different factors which are responsible for the onset of the monsoons? Apart from the factors which I have mentioned, there are certain other factors which strengthen the monsoons, like subtropical jet streams, like tropical easterly jet streams, intertropical convergence zone shift. So, these are the other factors which are responsible for strengthening the monsoon. So, see this here in this case, for example, so here you have got Somalian jet, the Somalian jet flowing from the Arabian Sea towards India. So, you have got a subtropical jet flowing in this direction. So, here these subtropical jets further help in strengthening the monsoons. These jet streams are upper air circulation at the tropopause develop certain jet streams at the confluence of these latitudes in the the polar cell and the northern Ferrel cell. So between the Ferrel cell and Hadley cell, there are certain jet streams. So one is the Somalian jet, the second is the subtropical jet, further strengthen the monsoons. Apart from the shift of the 𝗖𝗃𝗃𝗃, low pressure trough created at the Tibetan plateau further strengthens the monsoons. So because of the dominance of landmass creates more low pressure. So the shift of 𝗖𝗃𝗃𝗃, the red line, is shifted more to the north in the summer when relatively compared with the blue line of 𝗖𝗃𝗃𝗃 during the winter season. So these are the apparent migration. So when you are representing, especially in the case of mains, when you are writing about monsoons, you need to present these two diagrams in a rough sketch. One is mentioning the summer condition with the development of southwest monsoon. The second is the development of northeast monsoon during winter. Don't just draw a single map of southwest monsoons, showing that northeast monsoons flowing towards India, which are a dry air but leads to precipitation in the Tamil Nadu regions because they pick up the moisture from the Bay of Bengal. So the other factor which influences is Walker circulation flow. So this Walker circulation is a kind of flow which is responsible for the flow of wind here in the Pacific Ocean region in the Australia. So the northern part of Australia, when the winds are flowing from Australia towards India, strengthen the monsoon. So part of Walker circulation, which is part of Pacific Ocean, helps in strengthening the monsoon in this direction. The impact of Indian Ocean dipole. So the Indian Ocean dipole also impacts the monsoon. So here, because of the cold and warm conditions, because of the low and high pressure conditions, because of the change in the Indian Ocean dipole, the wind direction changes. So in this condition, what happens is, in the negative condition, it strengthens the monsoons and impacts the monsoons, the Indian Ocean dipole, because of the variation of temperature conditions. One is a cool climatic condition and one is a warm climatic condition. These conditions impact the Indian monsoons. So the high pressure condition leads to development of northeast monsoons. In the case of tertiary circulation, so friends, we shall meet in the next session regarding discussing with different topics. Thank you.